in exactly 48 hours, something will happen that has never occurred in human history. An object from beyond our solar system, traveling at 137,000 miles per hour, will pass within 18 million miles of Mars, and we are going to photograph it at unprecedented resolution for the first time. But here's where everything you think you know about space, about physics, about what's possible in our universe, gets turned completely upside down. This thing is 33 billion tons. Let that number sit with you for a moment. 33 billion tons. That's 3 to 5 orders of magnitude heavier than any interstellar object we have ever detected. To put this in perspective, if you took every asteroid between Earth and Mars and combined them, you'd still be nowhere close to this mass. It has no tail. Even though instruments have confirmed it's spewing 150 kilograms of material into space every single second, the glow points forward, not backward. This violates everything we understand about how objects behave when they approach the sun. It emits nickel without iron, which violates basic stellar chemistry that has held true for every single astronomical object we've studied in over a century of observation. The spectral signature is impossible according to our current understanding of how elements form in stars and distribute through space and its trajectory. Its trajectory perfectly aligns with our solar system's plane, a statistical impossibility with a 0.2% chance of occurring naturally. But it gets stranger. The minimum orbit intersection distance to Mars is only 2.7 million kilometers. For an object that's been traveling through interstellar space for millions or billions of years, to pass this close to a planet's orbital path requires precision, mathematical precision. Harvard's R.V. Loeb, the same scientist who studied Oumuamua and faced ridicule from the scientific establishment, has given this object a 6 out of 10 on his scale for being artificial technology. Not 1, not 2, 6 out of 10. In the scientific community, where careers are destroyed for suggesting anything beyond conventional explanations, this is earth-shattering. Meanwhile, as if the universe is orchestrating some cosmic revelation, NASA just published peer-reviewed evidence of potential ancient life in leopard-spotted rocks on Mars. The same week that HSBC became the first bank to use quantum computing in real-world trading, beating classical computers by 34%. The same week GPT-5 launched and users revolted, calling it lobotomized. The same week that France sustained nuclear fusion for 22 minutes straight and China's carbon emissions dropped for the first time in history. It's October 2025, and science is moving so fast that yesterday's breakthroughs are already old news. But what if these aren't separate events? What if there's a pattern here that goes deeper than coincidence? In the next several hours, we're going to connect every single dot. From the interstellar anomaly passing Mars in less than 2 days to the quantum computers going live on Wall Street. From the AI that users say lost its soul to the resurrection of extinct birds. From medical miracles curing diseases we thought were incurable to the geopolitical chess game being played in the shadows of space agencies worldwide. Some of these stories the mainstream media buried completely. Others they reported without understanding the implications. And a few they're actively trying not to talk about. Because when you connect these dots, when you see the pattern that emerges, it points to something so significant that it challenges everything we thought we knew about our place in the universe. This isn't about conspiracy theories. This is about data. Peer-reviewed, published, scientifically validated data that, when viewed together, tells a story that the individual pieces cannot. The object we're calling 3I Atlas is now less than 48 hours from its closest approach to Mars. Multiple spacecraft are turning their cameras toward this visitor at the exact same moment. The Mars Reconnaissance Orbiter, China's Tianwen-1, ESA's Mars Express and ExoMars Trace Gas Orbiter, all coordinating to capture images with resolution we've never had before, 30 kilometers per pixel. That doesn't sound impressive until you realize what it means. For the first time, we will be able to separate the nucleus of this object from its surrounding dust cloud. We will see its actual shape, its surface features, whether it's tumbling randomly or rotating in a controlled manner. We will see if this is a natural chunk of ice and rock, or something else entirely. The urgency in the scientific community is palpable. Mars orbiters weren't designed to photograph objects millions of kilometers away in space. They were built to study Mars. But when researchers realized that 3I Atlas would pass close enough for planetary spacecraft to image it clearly, there was a scramble. Observation schedules that normally take months to approve were rewritten in days. Mission priorities were completely reorganized. Why the rush? Because this opportunity doesn't come back. Ever. 3I Atlas is moving at interstellar velocities. After it passes Mars, it continues inward toward the Sun, reaching perihelion on October 29th. Then it's gone, flung back out into the cosmos by the Sun's gravity, accelerating away from us forever. We get one chance, one window, one moment to answer questions that could rewrite our understanding of what's possible in this universe. And that window opens in exactly 47 hours and 36 minutes from the moment I'm speaking these words. But here's what makes this even more extraordinary. The teams running these orbiters, the scientists who have dedicated their careers to studying Mars, weren't planning to do this. The coordination, the technical challenges, the diplomatic negotiations between space agencies that don't always cooperate, it all happened in a matter of weeks. This suggests something that mainstream science reporting isn't discussing. The scientific establishment, despite its public caution and conservative statements, is taking 3IATLs very seriously, more seriously than they're admitting in press releases and journal papers. When you have multiple space agencies suddenly coordinating their most sophisticated instruments, when you have mission controllers completely reorganizing billion-dollar spacecraft schedules, when you have researchers putting their reputations on the line to capture these images, that tells you something. It tells you that behind closed doors, away from public scrutiny, some very smart people think this object might be something extraordinary, and in 47 hours and 32 minutes, we find out if they're right. The question isn't whether 3I Atlas is unusual. Every single measurement confirms it's unlike anything we've ever encountered. The question is whether unusual means naturally rare or artificially guided. Whether we're looking at the most improbable cosmic coincidence in recorded history or evidence that we are not alone. October 3rd, 2025. Mark your calendar. Because either way, we're about to learn something profound about our place in the universe. 6 days ago, Avi Loeb and his colleagues published a paper that should have made front-page headlines around the world. It didn't. The paper appeared in the Astrophysical journal Letters, passed through rigorous peer review, and quietly entered the scientific record with barely a whisper from mainstream media. What that paper revealed changes everything we thought we knew about interstellar space and what can survive the journey between star systems. The researchers analyzed over 4,000 observations of 3I Atlas collected by 227 observatories worldwide between May 15th and September 23rd. They weren't just looking at pretty pictures, they were hunting for something specific: non-gravitational acceleration. When a comet gets close to the Sun, ice on its surface turns directly from solid to gas through a process called sublimation. This outgassing acts like tiny rocket thrusters, pushing the comet slightly off its gravitational trajectory. Every active comet we've ever studied shows this effect. It's one of the defining characteristics of what makes a comet. A comet, 3I Atlas, shows no detectable non-gravitational acceleration. None whatsoever. Now let that sink in for a moment. The Webb Space Telescope has confirmed that this object is losing 150 kilograms of mass every single second. That's 330 pounds of material being ejected into space continuously. The outflow speed is 440 meters per second, nearly 1,000 miles per hour. This isn't a subtle effect. This is a massive, continuous rocket thrust that has been happening for months as the object approaches the Sun. When you plot the trajectory of 3I Atlas with exquisite precision using thousands of observations from observatories around the world, it follows a purely gravitational path. The residual acceleration, the deviation from what gravity alone predicts, is less than 15 centimeters per day squared. To put that in perspective, that's about 100,000th of Earth's surface gravity, essentially zero. How do you have a continuous rocket thrust of this magnitude and see essentially no acceleration? There's only one way. The object has to be absurdly massive, so massive that the thrust, even though it's enormous in absolute terms, becomes negligible compared to the object's inertia. The calculation is straightforward physics. Given the observed mass loss rate and outflow speed, the lack of measurable acceleration implies a minimum mass of 33 billion tons. 33 billion tons gives you a minimum diameter of 5 kilometers if you assume solid density. 5 kilometers is not the 20-kilometer estimate from early brightness observations. It's smaller, but it's still huge. It's still at the very top end of the size range that Hubble observations allow, and it's still 3 to 5 orders of magnitude more massive than Oumuamua. Here's the problem that nobody in the scientific community has a good answer for. Where do 33 billion-ton interstellar objects come from? The mass budget of heavy elements in interstellar space is limited. Rocky material, the stuff that makes planets and asteroids, has to be ejected from planetary systems. Planets form around stars. When those planetary systems evolve, some material gets flung out into interstellar space through gravitational interactions. That's where Oumuamua came from. That's where 2I Borisov came from. That's the reservoir we're drawing from when we detect interstellar visitors. But that reservoir has a size distribution. Small objects are common. Large objects are rare. Exponentially rare. The statistics are brutal and unforgiving. If you do the math, and Loeb's team did exactly this calculation in their paper, the interstellar mass reservoir can only deliver a 20-kilometer rock to the inner solar system about once every 10,000 years. Even if you pack all the available interstellar rocky material into 20-kilometer chunks, which is absurdly optimistic, you still only get visits once every 10,000 years. We've been seriously looking for interstellar objects for less than a decade, and we found one. The odds of that happening by chance are vanishingly small. It's like buying a lottery ticket and winning the jackpot on your first try, then winning again on your second try. The probability is so low that it approaches mathematical impossibility. Unless, and here's where we have to consider uncomfortable possibilities, unless the size distribution we're assuming is wrong, unless there's a population of massive interstellar objects that doesn't follow the statistical rules we derive from studying our own solar system, unless 3I Atlas is not a random chunk of ice and rock that happened to wander through our neighborhood, unless it's something else entirely. This is why Loeb rates it 6 out of 10 on his artificial technology scale, not because any single measurement definitively proves artificial origin, but because the accumulation of statistical improbabilities, when taken together, becomes more compelling than the natural explanation. Think about what 33 billion tons means in practical terms. That's more massive than most asteroids in our solar system. That's comparable to some of the larger moons of the outer planets. For something this massive to be wandering between star systems suggests either an incredibly violent ejection event or deliberate construction. Natural ejection mechanisms have limits. When planets form, when star systems evolve, the chunks that get thrown out into interstellar space follow predictable patterns. Big chunks are harder to eject. They require more energy, more precise gravitational interactions. The bigger the chunk, the rarer the circumstances needed to fling it between stars. But if you were constructing something, if you were building an object designed to travel between star systems, mass might not be a limitation. It might be an advantage. More mass means more stability against the radiation pressure of stars. More mass means more internal volume for whatever systems might be needed for interstellar travel. More mass means more momentum to maintain course over vast distances and timescales. The lack of non-gravitational acceleration, which seems impossible for a natural comet, makes perfect sense for an artificial object. If 3I Atlas has some form of attitude control, some way of maintaining orientation and trajectory, then the outgassing we observe might not be random sublimation. It might be controlled venting, maintaining internal pressure or temperature while preserving the object's course. This would explain why the glow points forward instead of backward. Instead of material being blown away by solar radiation, creating a typical comet tail, we might be seeing controlled exhaust from systems designed to maintain stability during the approach to our Sun. The chemistry adds another layer to this puzzle. Nickel without iron appears in the spectral observations, but this combination doesn't occur naturally in any stellar environment we understand. Nickel and iron are chemically similar, form under similar conditions. In every astronomical object we've studied, when you see one, you see both. The ratio varies, but both are always present. 3I Atlas violates this rule. Clean nickel lines in the spectrum. Iron lines absent. Not below detection threshold. Simply not there. You cannot preferentially form nickel without iron through any stellar nucleosynthesis process we know about. You cannot chemically separate them after formation, because they behave almost identically. You cannot selectively deplete one through sublimation, because they sublime at similar temperatures. Unless the materials were processed, refined, purified through some method that doesn't occur in natural stellar or planetary environments. Unless we're looking at manufactured materials with compositions optimized for specific purposes rather than the random mixtures that nature produces. Every measurement, every analysis, every statistical calculation points in the same direction, not definitively, not beyond all doubt, but consistently. 3. Atlas doesn't fit the natural explanation. The pieces don't add up. The probabilities don't work out. The chemistry doesn't make sense. But it fits perfectly if we're looking at something artificial, something designed, constructed, and sent on a trajectory that brings it through our solar system at exactly the right time for detailed observation by our most advanced spacecraft. In 45 hours and 18 minutes, we'll have high-resolution images. We'll see the surface features, the shape, the structure. We'll know if we're looking at a lumpy, irregular chunk of natural rock and ice, or something with geometry that nature doesn't produce. The mathematics of coincidence are running out of room for natural explanations. Multiple spectroscopic observations have confirmed something that should be impossible according to everything we understand about stellar chemistry and planetary formation. 3I Atlas is emitting nickel, pure nickel, without any detectable trace of iron. This isn't a minor anomaly. This isn't something that can be explained by measurement error or unusual but natural processes. This is a complete violation of basic stellar nucleosynthesis that has held true for every single astronomical object we've studied in over a century of observation. Let me explain why this matters. Because the implications go far beyond simple chemistry. In every natural astronomical object we've ever analyzed, every asteroid, every comet, every meteor, every piece of space debris, nickel and iron appear together. They're what chemists call sister elements. They form through identical nuclear fusion processes in the cores of massive stars. They have similar atomic weights, similar chemical properties, and virtually identical behavior under the conditions found in space. When massive stars explode as supernovae, they scatter these elements into interstellar space in specific ratios. When new stars and planetary systems form from that material, the nickel to iron ratio remains consistent. It varies slightly depending on the exact stellar processes involved, but both elements are always present together. This isn't just theory. We've measured this relationship in thousands of astronomical objects across different regions of our galaxy. Rocky asteroids, metallic meteorites, cometary nuclei, interstellar dust clouds, the pattern holds everywhere we look. Nickel and iron are cosmic companions. Where you find one, you find the other. 3. iAtlas breaks this rule completely. The spectral analysis is unambiguous. Clear nickel emission lines at precisely the wavelengths we expect, but the ion lines that should accompany them, they're simply not there. Not faint, not partially masked by other emissions. They're absent entirely. The instruments are sensitive enough to detect ion if it were present in the ratios we expect from natural stellar processes. The observation conditions were excellent. Multiple independent teams have confirmed the results. This isn't observational error or instrumental limitation. We are looking at nickel without iron, and there is no known natural process that can produce this signature. But there are artificial processes that could explain it. Industrial refining and purification can separate nickel from iron. On Earth, we routinely produce high-purity nickel for specialized applications where iron contamination would be problematic. Advanced metallurgy can create nickel alloys with specific properties optimized for particular uses. If 3I Atlas were constructed rather than naturally formed, if we're looking at manufactured materials rather than the random combinations that stellar processes produce, then pure nickel makes sense. It has properties that might be valuable for interstellar travel. Nickel has excellent corrosion resistance, maintains its structural integrity across wide temperature ranges, and has favorable magnetic properties. For an object traveling through the radiation and temperature extremes of interstellar space for potentially millions of years, these characteristics could be crucial. The absence of iron also suggests something even more intriguing. Iron oxidizes readily, forms compounds that can be structurally weak or chemically reactive. If you were designing materials for long-term stability in the harsh environment of space, removing iron contamination would be one of your first priorities. This level of material purity and optimization doesn't occur in nature. Natural processes are messy, random, governed by whatever elements happen to be available when planets and asteroids form. You get mixtures, composites, randomly distributed impurities and variations. But engineering is different. Engineering selects specific materials for specific purposes. It optimizes compositions for desired properties. It eliminates elements that would compromise performance or longevity. The spectral signature of 3I Atlas looks less like a natural object and more like a carefully engineered component. There's another possibility that's even more unsettling. What if the nickel emission isn't coming from the object's bulk composition? What if we're seeing the spectral signature of surface systems, active systems that are functioning during its passage through our solar system? Nickel is commonly used in advanced alloys for high-temperature, high-stress applications. Rocket nozzles, heat exchangers, components that need to maintain structural integrity under extreme conditions. If 3I Atlas has active systems, propulsion, thermal management, attitude control, we might be seeing the spectral signature of those systems operating. This would explain why the emission appears to be coming from the forward-facing region of the object. Instead of random sublimation from a natural surface, we might be observing controlled emissions from engineered systems designed to function during the object's closest approach to the Sun. The timing supports this interpretation. The nickel signature has become more pronounced as 3I Atlas approaches the inner solar system. Natural sublimation would produce a more random pattern of emissions as different surface materials reach their volatilization temperatures, but engineered systems might activate at specific temperatures or distances, producing the consistent emission pattern we observe. Consider also the energy requirements. Natural sublimation is a passive process driven by solar heating, but the emission rates we're measuring from 3I Atlas require significant energy input. 150 kilograms per second of material ejection at nearly 1,000 miles per hour represents enormous energy expenditure. Where is that energy coming from? Natural comets derive their energy from solar heating, converting ice to gas. But the energy balance doesn't work for 3I Atlas. The solar heating at its current distance isn't sufficient to drive the observed emission rates if we assume natural sublimation processes. Unless there's an internal energy source. unless the object has systems that can generate and direct energy for specific purposes. Unless we're not looking at passive sublimation but active emission from powered systems, the chemical evidence keeps pointing in the same direction. Materials that don't occur naturally, emission patterns that require energy sources beyond simple solar heating, spectral signatures that suggest engineering rather than random natural processes. Every alternative explanation requires invoking special circumstances, unusual conditions, or processes that have never been documented in any other astronomical object. The natural explanations become increasingly contrived and improbable, but the artificial explanation, the possibility that 3I Atlas is constructed rather than naturally formed, explains all the observations consistently. The mass, the chemistry, the emission patterns, the energy requirements, they all make sense if we're looking at technology rather than geology. The scientific establishment resists this conclusion because it's extraordinary. It challenges fundamental assumptions about our place in the universe and the likelihood of encountering evidence of other technological civilizations. The career risks for researchers who publicly support such interpretations are severe, but the data doesn't care about career concerns or institutional preferences. The spectroscopic evidence is clear, reproducible, and verified by multiple independent observations. We are seeing chemistry that should not exist in any natural object formed through stellar processes. We are seeing emission patterns that require energy sources and material compositions that nature doesn't produce. We are seeing evidence of engineering on an interstellar scale. In 43 hours and 7 minutes, we'll have high-resolution images that show us the surface structure and geometry of this object. If those images reveal regular patterns, geometric shapes, or surface features that suggest construction rather than natural formation, the chemical evidence becomes even more compelling. The universe may be about to tell us something we've been wondering about for centuries. We may not be alone. And the proof may be passing through our solar system at 137,000 miles per hour, advertising its artificial nature through chemistry that violates every rule we thought we understood about how objects form in space. There are roughly 100 billion stars in our galaxy. Each star system occupies a volume of space measured in cubic light-years. The odds of an object ejected randomly from another star system happening to pass through our solar system are astronomical. Literally astronomical. But 3I Atlas didn't just randomly pass through our solar system. Its trajectory shows a level of precision that transforms astronomical odds into mathematical impossibility. The object is traveling almost perfectly in the plane of our solar system's planets. The ecliptic alignment has a probability of occurring naturally of just 0.2%. That alone is unusual but not unprecedented. Rare coincidences do happen in a universe as vast as ours, but the trajectory has other properties that stack coincidence upon coincidence until the accumulated improbability becomes difficult to accept. 3I Atlas passes unusually close to Venus, Mars, and Jupiter. Not close enough to be captured or significantly deflected, but closer than a random interstellar trajectory should allow. The minimum orbit intersection distance to Mars, the closest that 3I Atlas's path comes to Mars's entire orbital path, is only 2.7 million kilometers. For context, that's about 7 times the Earth-Moon distance. For an object coming from interstellar space on a trajectory that was set millions or potentially billions of years ago, passing that close to a planet's orbit represents extraordinary precision. Think about what this means in practical terms. When 3I Atlas was ejected from its origin system, whenever and wherever that occurred, its initial velocity had to be calibrated to within fractions of a percent to achieve this trajectory. A tiny deviation in speed or direction would have sent it far from our solar system entirely, or caused it to arrive at a different time when planetary alignments were unfavorable for close observation. The precision required is equivalent to shooting an arrow from Los Angeles and hitting a specific grain of sand on a beach in Tokyo. Except instead of thousands of miles, we're talking about distances of light years and time spans of millions of years. Natural ejection events don't produce this kind of precision. When objects are flung out of planetary systems through gravitational interactions, the process is chaotic. Close encounters between planets, stellar passes, or other dynamic events create complex trajectories that are extremely sensitive to initial conditions. Small variations in the exact timing, the planetary positions, the gravitational field strengths during the ejection event produce wildly different outcomes. The overwhelming majority of ejected objects end up on trajectories that never encounter another star system. Those that do encounter other systems arrive at random times from random directions with random approach parameters. But 3I-ATLS arrives at exactly the right time when our technology is capable of detailed observation. It approaches from a direction that allows optimal imaging by our Mars-orbiting spacecraft. Its closest approach distance provides unprecedented resolution, without being so close as to prevent observation. If this were a natural coincidence, we should expect interstellar visitors to arrive from random directions at random times with random trajectories that don't necessarily align with our observational capabilities. We should see objects passing through the outer solar system where we can barely detect them, or approaching too quickly for detailed study, or arriving when our spacecraft are poorly positioned for observation. Instead, we get an object whose trajectory seems almost optimized for scientific observation by human technology in October 2025. The timing itself is suspicious. 3I Atlas was first detected in January 2025, giving the scientific community exactly enough time to coordinate observations, reschedule spacecraft, and prepare instruments for detailed study. Not so much time that interest would wane or funding would be redirected to other projects, but enough time for proper preparation. If the object had been detected years earlier, bureaucratic processes and changing priorities might have prevented the coordinated observation campaign we're seeing now. If it had been detected just months ago, there wouldn't have been sufficient time to organize the complex international cooperation required to redirect Mars orbiters toward the target. The detection timing window was perfect for maximizing scientific return from this encounter. Consider also the object's perihelion date, October 29th, 2025. This gives researchers nearly a month of detailed observations as 3I Atlas approaches the Sun, passes through the inner solar system, and begins its departure. Long enough for multiple observation campaigns, spectroscopic analysis, trajectory refinement, and international coordination of resources. Natural objects don't optimize their schedules for human convenience. But if 3I Atlas were designed to be studied, if its trajectory were calculated to provide maximum opportunity for scientific observation, the timing and approach parameters would look exactly like what we're observing. The trajectory also suggests something else that's rarely discussed in scientific papers, but is obvious to anyone who understands orbital mechanics. 3I Atlas is not just passing through our solar system, it's conducting a systematic survey. The path takes it close enough to multiple planets to conduct detailed observations using advanced sensors. If the object has instruments capable of analyzing planetary atmospheres, magnetic fields, or surface compositions, its trajectory provides optimal geometry for studying Earth, Mars, and Jupiter. For Venus, the approach distance allows atmospheric analysis and possibly surface mapping through radar or other penetrating sensors. For Mars, the timing coincides with favorable atmospheric conditions and surface visibility. For Jupiter, the trajectory provides access to both the planet itself and several of its largest moons. This isn't speculation. This is simply a description of what the trajectory enables from an observational standpoint. Whether 3I Atlas takes advantage of these opportunities depends on what kind of object it actually is. But if it were a probe sent by another civilization to study our solar system, the trajectory we're observing would be exactly what mission planners would design to maximize scientific return while maintaining reasonable approach distances from potentially hazardous gravitational fields. The mathematical precision required to achieve this trajectory from interstellar distances is staggering. Not impossible for advanced technology, but essentially impossible for natural processes operating over cosmic timescales. When you combine the trajectory precision with the mass anomaly, the chemical impossibilities and the controlled emission patterns, the accumulated evidence points toward one conclusion that explains all the observations consistently. 3. Atlas may not be a natural visitor from another star system. It may be an artificial probe designed to study our solar system, arriving at a time when our own technology is capable of recognizing and analyzing evidence of its artificial nature. In 41 hours and 53 minutes, we'll have detailed images that may reveal surface features consistent with this hypothesis. Regular geometric patterns, symmetric structures, or organized surface components that nature doesn't produce randomly. The trajectory tells us where 3I Atlas came from and where it's going. But more importantly, it tells us that its path through our solar system was calculated with precision that suggests intelligence, planning, and purpose. Random natural events don't produce mathematical precision, but engineering does. Every comet we've ever observed follows the same basic pattern when it approaches the sun. As solar radiation heats the surface, ice sublimes directly from solid to gas, creating a cloud of vapor and dust around the nucleus. Solar wind and radiation pressure push this material away from the sun, creating the characteristic tail that always points away from the sun, regardless of the comet's direction of travel. This isn't just conventional wisdom. This is fundamental physics. The radiation pressure from the sun acts on tiny dust particles and gas molecules, accelerating them outward. The result is always the same: a tail of glowing material streaming behind the comet as it travels through its orbit. 3I Atlas violates this fundamental principle completely. Instead of a tail pointing away from the sun, the glow around 3I Atlas appears to be concentrated on the forward-facing side, the side pointing toward its direction of travel, not away from the sun. This is physically impossible for any natural comet following the laws of physics as we understand them. Let me be completely clear about what this means. We're not talking about a subtle variation in tail orientation or an unusual distribution of material around the nucleus. We're talking about a complete reversal of the physical processes that govern how objects behave in the solar system. Solar radiation pressure acts outward from the sun. Always. There's no mechanism by which it could push material toward the sun or concentrate it on the forward-facing side of an object moving through space. The physics simply doesn't work that way. Yet multiple independent observations confirm that the brightest emissions from 3I Atlas come from the region facing its direction of travel. High-resolution spectroscopy shows that the nickel emissions we discussed earlier are concentrated in this forward-facing region. Thermal imaging reveals heat signatures that don't match what we'd expect from passive solar heating. This pattern suggests that we're not looking at passive sublimation driven by solar heating. We're looking at active emissions from systems that can direct material in specific directions regardless of solar radiation pressure. Think about what this implies. Natural comets are passive objects. They respond to external forces, solar heating, radiation pressure, gravitational fields. They don't have mechanisms to actively direct their emissions or control the distribution of material around their nucleus. But engineered systems can be active. They can have propulsion systems, attitude control mechanisms, thermal management systems that vent material in controlled directions for specific purposes. If 3I Atlas has some form of propulsion system, even a low-thrust system designed for trajectory corrections or attitude control, the emissions from that system would appear concentrated in specific regions rather than distributed randomly around the object. The forward-facing concentration suggests a particularly interesting possibility. Instead of a propulsion system designed to accelerate the object, we might be seeing emissions from systems designed to protect it. At interstellar velocities, even tiny particles of dust and gas become dangerous projectiles. An object traveling at 137,000 miles per hour, encounters enormous mechanical stresses from impacts with interstellar material. A protective system, some form of deflector or impact mitigation system, might create emissions concentrated on the forward-facing side. Material vented forward could clear debris from the object's path, reducing impact damage during its journey through space. This interpretation also explains the energy requirements. We calculated earlier that the observed emission rates require more energy than simple solar heating can provide. But if the emissions come from active protective systems rather than passive sublimation, the energy could be supplied by internal power sources, nuclear reactors, advanced batteries, or energy storage systems that have been operating during the object's journey through interstellar space. The emission patterns also suggest temporal control. The intensity and distribution of the forward-facing glow has varied as 3I Atlas approaches the inner solar system. Natural sublimation would produce variations based on solar heating, which depends primarily on distance from the Sun and surface composition, but the variations we observe don't correlate well with solar distance. The emission patterns change in ways that suggest active control, systems that can modulate their output based on internal programming or external sensors rather than passive response to solar heating. This level of control implies not just engineering, but intelligent engineering, systems that can monitor conditions and adjust their operation accordingly. This goes beyond simple mechanical devices to suggest computational capabilities, sensors, and decision-making processes. The forward glow anomaly also provides a possible explanation for the lack of non-gravitational acceleration we discussed earlier. If 3I Atlas has active attitude control systems, they could compensate for the propulsive effects of material emission, maintaining a precise trajectory despite continuous mass loss. Natural comets can't do this. They have no way to compensate for the random forces created by outgassing. The result is always measurable deviation from purely gravitational trajectories. But engineered systems could maintain trajectory precision by using controlled emissions to counteract unwanted accelerations. The forward-facing emissions might be part of a sophisticated guidance system that keeps 3I Atlas on its intended path, despite the various forces acting on it during its passage through our solar system. This interpretation explains both the forward glow and the trajectory precision simultaneously. We're not looking at two separate anomalies that require different explanations. We're looking at one integrated system that uses controlled emissions for both protection and guidance. The implications extend beyond just this one object. If 3I Atlas represents technology from another civilization, the forward-facing protective systems suggest that interstellar travel is not just theoretically possible but practically achievable. The engineering challenges of interstellar travel are enormous. Radiation damage, impact erosion, maintaining structural integrity over millions of years, preserving functionality across temperature extremes. These problems have solutions, and 3I Atlas might be demonstrating some of those solutions in real time. The forward glow tells us that interstellar travel technology exists and functions reliably over cosmic distances and timescales. It tells us that the engineering problems we think are insurmountable may have elegant solutions that we haven't discovered yet. In 39 hours and 47 minutes, high-resolution imaging will show us the surface structure of the region producing these forward-facing emissions. If we see geometric patterns, organized structures, or surface features that suggest engineered systems rather than random natural formations, the forward glow anomaly becomes powerful evidence for artificial origin. The physics of natural comet behavior is well understood and has been confirmed by decades of observation. 3I Atlas doesn't follow those rules. Instead, it demonstrates capabilities that suggest intelligence, engineering, and purposes beyond what random natural processes can achieve. The universe may be showing us that the gap between what we think is possible and what actually is possible is much larger than we imagined. Professor Avi Loeb created his artificial technology scale for exactly situations like this. a quantitative framework for evaluating objects that don't fit natural explanations without requiring scientists to make binary determinations between definitely natural and definitely artificial. The scale runs from 0 to 10. 0 means definitively natural, explainable entirely through conventional astrophysics and planetary science. 10 means definitively technological, with characteristics that can only be explained through intelligent design and engineering. Loeb has assigned 3 IATLAS a score of 6. To understand the significance of this rating, you need to understand both Loeb's background and the intellectual courage required to make such a statement in the current scientific environment. Loeb is not a fringe researcher or conspiracy theorist. He's the Frank B. Baird Jr. Professor of Science at Harvard University, former chair of Harvard's Astronomy Department, and one of the most cited theoretical astrophysicists of his generation. His research on black holes, cosmic reionization, and the first stars helped establish our current understanding of cosmic evolution. When Oumuamua was discovered in 2017, Loeb was among the first scientists to systematically analyze its anomalous properties and consider non-natural explanations. His book Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, argued that Oumuamua's characteristics, its unusual shape, reflectivity and trajectory modifications, were more consistent with artificial technology than natural formation. The scientific establishment's response was swift and harsh. Colleagues distanced themselves from his conclusions. Academic conferences became uncomfortable. Grant applications faced additional scrutiny. Career advancement for his graduate students became more difficult. This is how the scientific community handles researchers who venture beyond acceptable boundaries of speculation, not through open debate or data-driven discussion, but through social and professional pressure that makes it costly to pursue unconventional hypotheses. Yet Loeb persisted. He continued analyzing data, publishing papers, and refining his theoretical framework for evaluating potential evidence of extraterrestrial technology. The artificial technology scale emerged from this work, a tool for quantifying the strength of evidence without requiring definitive conclusions that could destroy careers. For 3 IATLAS to receive a rating of 6 means that Loeb, despite knowing the professional risks, considers the evidence compelling enough that dismissing artificial origin without serious consideration would be scientifically irresponsible. Let's examine what a rating of 6 means in practical terms. Objects rating 0 to 2 on the scale have characteristics fully explainable through conventional astrophysics. They might be unusual or rare, but they don't violate known physical principles or require special circumstances to explain their properties. Objects rating 3 to 4 show some anomalous characteristics, but can still be explained through natural processes if you invoke unusual but plausible conditions, perhaps rare formation mechanisms, atypical compositional variations, or uncommon environmental factors. Objects rating 5 represent a threshold. They have characteristics that strain natural explanations. Multiple anomalies that, while not individually impossible to explain naturally, become increasingly improbable when considered together. 6 represents significant evidence for artificial origin. Not proof, not certainty, but evidence strong enough that the artificial hypothesis becomes competitive with natural explanations. At this level, dismissing the artificial possibility without detailed analysis becomes scientifically unreasonable. For 3 IATLAS, the evidence supporting a rating of 6 includes every anomaly we've discussed, the impossible mass for natural interstellar objects, the violation of basic stellar chemistry in its nickel without iron signature, the mathematical precision of its trajectory, the forward-facing emissions that contradict comet physics, the lack of non-gravitational acceleration despite massive outgassing. Each anomaly individually might be explained through special circumstances or unusual natural processes, but the combination of all these anomalies in a single object pushes the accumulated improbability beyond what random chance can reasonably explain. This is Bayesian reasoning applied to astronomical data. When multiple independent lines of evidence all point in the same direction, the cumulative probability becomes much stronger than any individual piece of evidence. Loeb's rating also reflects the object's behavior during its passage through our solar system. Natural objects are passive. They respond predictably to gravitational fields, radiation pressure, and thermal gradients. Their evolution follows well-understood physical laws. 3. IATLAS demonstrates what appears to be controlled behavior, emissions that correlate with position and time in ways that suggest internal programming rather than passive response to external forces. Trajectory maintenance despite forces that should cause measurable deviations. Energy expenditure that exceeds what natural processes can supply. The timing of its arrival adds another dimension to the evidence. 3. IATLAS appears at exactly the moment when human technology is sophisticated enough to recognize and analyze potential evidence of artificial origin. Our spectroscopic capabilities, orbital mechanics understanding, and international coordination of space-based assets have only recently reached the level needed to properly study such an object. This temporal coincidence could be random, but it could also be intentional. If 3i Atlas were designed to reveal its nature to emerging technological civilizations, its arrival timing would be calibrated to coincide with the development of appropriate analytical capabilities. Loeb's 6 rating also acknowledges the limitations of our current data. We don't have definitive proof of artificial origin. We don't have images showing obvious technological structures. We don't have detected signals or communications. The evidence is circumstantial, based on physical measurements that are difficult to explain through natural processes. But circumstantial evidence can be compelling when it's consistent, reproducible, and verified by multiple independent observations. In legal systems, circumstantial evidence regularly supports conclusions beyond reasonable doubt. In science, circumstantial evidence guides research directions and theoretical development. The scientific method doesn't require absolute proof before considering hypotheses. It requires evidence, logical reasoning, and testable predictions. Loeb's artificial technology scale provides a framework for quantifying evidence strength without demanding premature certainty. A rating of 6 means that the artificial hypothesis deserves serious scientific attention. It means that research programs focused on detecting and analyzing potential extraterrestrial technology should prioritize objects like 3i-ATLS. It means that dismissing such objects without thorough investigation represents scientific bias rather than scientific rigor. The institutional resistance to Loeb's work reveals something troubling about the current state of academic science. The same community that celebrates intellectual curiosity and paradigm-shifting discoveries becomes conservative and risk-averse when confronted with evidence that challenges fundamental assumptions about our place in the universe. Yet paradigm shifts are how science advances. Plate tectonics was rejected by the geological establishment for decades before overwhelming evidence forced acceptance. Continental drift, stellar nucleosynthesis, black holes, dark matter, dark energy, all faced institutional resistance before becoming accepted science. The resistance to considering artificial explanations for anomalous objects reflects a cultural bias rather than scientific reasoning. The assumption that we are alone in the universe, that Earth represents the only technological civilization in our cosmic neighborhood, is not based on evidence. It's based on a lack of evidence, which is not the same thing. But we may be transitioning from a lack of evidence to the presence of evidence. Objects like 3i Atlas, with their accumulation of anomalous characteristics, represent potential data points in this transition. Loeb's 6 rating is a statement that this transition deserves serious scientific attention, not uncritical acceptance, not abandonment of rigorous analysis, but recognition that extraordinary claims require extraordinary investigation, not extraordinary dismissal. In 37 hours and 31 minutes, we'll have high-resolution images that may push 3i Atlas higher or lower on the artificial technology scale. Surface structures that clearly indicate natural formation would lower the rating. Geometric patterns, organized features, or technological signatures would raise it. But regardless of what those images reveal, Loeb's current rating of 6 represents a significant statement from one of the world's leading astrophysicists. It's a statement that the evidence for artificial origin is strong enough to warrant serious consideration and continued investigation. The scientific community may not be ready to accept such conclusions, but the universe doesn't wait for our acceptance. It presents evidence according to its own timeline, and that evidence may be telling us that we are not alone. In exactly 36 hours and 14 minutes, something unprecedented in human history will occur. Multiple spacecraft orbiting Mars will simultaneously turn their most sophisticated cameras toward a visitor from another star system and capture images with resolution never before achieved for an interstellar object. This isn't just routine astronomical observation. This is a carefully orchestrated international effort involving space agencies that don't always cooperate, using billion-dollar spacecraft in ways they were never designed for, risking mission objectives and equipment to capture images that may answer one of the most fundamental questions in science. Are we alone in the universe? The spacecraft involved read like an inventory of humanity's greatest technological achievements in space exploration. NASA's Mars Reconnaissance Orbiter, equipped with the high-rise camera capable of distinguishing features as small as a few meters from orbit. China's Tianwen-1, demonstrating that the new space race extends to the search for extraterrestrial intelligence. ESA's Mars Express and ExoMars Trace Gas Orbiter, representing European commitment to answering questions that transcend national boundaries. These spacecraft weren't built to photograph objects millions of kilometers away in space. They were designed to study Mars, its geology, atmosphere, potential for life, and suitability for human exploration. Their cameras, spectrometers, and other instruments are optimized for planetary science, not interstellar visitor analysis. But when the global astronomical community realized that 3I Atlas would pass close enough to Mars for spacecraft, originally designed for planetary observation to achieve unprecedented resolution of an interstellar object, everything changed. Mission control centers that normally plan operations months in advance suddenly found themselves rewriting schedules in days. International agreements that typically require years of negotiation were hammered out in weeks. Spacecraft pointing sequences that undergo extensive testing and validation were modified and uploaded with minimal preparation time. The technical challenges are staggering. These spacecraft must track a target moving at interstellar velocities while maintaining precise pointing accuracy. They must coordinate their observations to capture images from different angles simultaneously, providing stereoscopic views that can reveal three-dimensional structure. They must balance optimal imaging conditions with orbital mechanics constraints and power limitations. The fact that this coordination is happening at all tells you something crucial about how seriously the scientific establishment is taking 3I Atlas, despite their public caution and conservative statements. When space agencies risk expensive missions, when international cooperation overcomes political tensions, when technical teams work around the clock to modify carefully planned operations, that indicates a level of urgency and importance that goes far beyond routine scientific curiosity. The resolution these spacecraft will achieve is unprecedented for interstellar objects. 30 kilometers per pixel doesn't sound impressive until you realize what it means in practical terms. For the first time, we will be able to distinguish between the solid nucleus of 3I Atlas and its surrounding dust and gas envelope. We will see its actual shape, not just the fuzzy glow that ground-based telescopes can detect. We will identify surface features, structural details and patterns that could reveal whether we're looking at a natural chunk of ice and rock or something that was designed and constructed. Natural objects formed through random accretion and collision processes show characteristic patterns, irregular shapes, rough surfaces, impact craters, compositional variations that reflect chaotic formation histories. These patterns are well understood from studying asteroids, comets, and other natural bodies throughout our solar system. Artificial objects show different patterns: geometric regularity, smooth surfaces, organized structures, symmetries that don't occur in random natural processes. These patterns reflect intelligent design, engineering optimization, and construction techniques. The images captured in 36 hours will show us which Category 3 ATLAS belongs to. But there's another dimension to this observation campaign that's rarely discussed in scientific papers or press releases. The timing window isn't just optimal for image resolution, it's optimal for detecting activity. If 3I Atlas has systems that activate during its closest approach to the Sun, if it has instruments or sensors designed to study our solar system, if it has communications equipment or other technological capabilities, those systems would likely be most active during this critical phase of its trajectory. The energy available from solar radiation is highest during closest approach. If 3I Atlas has solar collectors or thermal conversion systems, they would be operating at maximum efficiency. If it has sensors that require power, they would have maximum energy available for operation. The spacecraft observing 3I Atlas will be monitoring not just for static structural features, but for changes over time. Variations in brightness, modifications in emission patterns, alterations in surface appearance that might indicate active systems responding to changing conditions. These temporal variations could provide the most compelling evidence for artificial origin. Natural objects evolve slowly and predictably as they approach the Sun. Artificial objects might demonstrate controlled changes, systematic responses, or organized activities that reveal their technological nature. The coordination between spacecraft also enables detection of phenomena that single-point observations might miss. If 3I Atlas emits directed signals, communicates with other objects, or demonstrates position-dependent behavior, the multiple observation points will provide the parallax and timing information needed to identify and analyze such activities. There's also the possibility of interactive observation. If 3I Atlas is monitoring our solar system, it will certainly detect the electromagnetic emissions from our spacecraft, our communication systems, and our technological infrastructure. An intelligent probe might respond to the recognition that it's being observed by a technological civilization. Such responses could be subtle, changes in orientation, modifications in emission patterns, or alterations in trajectory that indicate awareness of our observation efforts. The coordinated spacecraft observations will be sensitive enough to detect such responses if they occur. The international cooperation aspect of this observation campaign also reflects geopolitical realities that extend beyond pure science. If 3I Atlas proves to be artificial, if we're looking at evidence of extraterrestrial technology, the implications extend far beyond academic astronomy. First contact protocols, information sharing agreements, and response coordination become critical issues. Which nation or organization has the authority to speak for humanity? How is information about potential extraterrestrial technology shared or controlled? What are the security implications of confirming that other technological civilizations exist? These questions explain why space agencies are coordinating their observations rather than competing for exclusive data. The stakes are too high for national competition. The implications too significant for any single country to manage alone. The 36-hour countdown also represents a psychological threshold for the researchers involved. Years of theoretical speculation, data analysis, and cautious scientific statements are about to be tested by direct observation. If the images reveal clearly natural features, irregular shapes, impact craters, rough surfaces consistent with random formation processes, then 3I Atlas joins the category of extremely unusual but ultimately natural objects. The anomalies we've discussed would require creative explanations, but the fundamental assumption that we are alone in the universe would remain intact. But if the images reveal geometric patterns, regular structures, or surface features that suggest intelligent design and construction, then everything changes. The scientific paradigm shifts. The philosophical implications become unavoidable. Humanity confronts the reality that we are not alone in the universe. There's no middle ground in this observation. The images will either support natural origin or they won't. The resolution is sufficient to distinguish between random natural patterns and organized artificial structures. In 35 hours and 58 minutes, we cross a threshold. Either we confirm that the universe occasionally produces natural objects so unusual that they mimic artificial technology, or we confirm that artificial technology exists beyond Earth and is currently passing through our solar system. The countdown has begun. The spacecraft are positioned. The cameras are calibrated. History waits for the shutter to click. On September 10th, 2025, while the scientific community was analyzing the trajectory and composition of 3I ATLAS, NASA published peer-reviewed evidence of potential ancient life on Mars. The timing wasn't coincidental scheduling. The timing was cosmically perfect. The paper describes analysis of a rock sample collected by the Perseverance rover in July 2024. A sample sealed in a tube, catalogued as Sapphire Canyon, containing what may be the first verified biological signatures from another planet in our solar system. The rock itself, officially named Shayava Falls, displays a pattern that on Earth would be immediately recognized as evidence of microbial life. Leopard-like spots of varying colors ranging from pale white to deep black, with streaks of green and blue minerals distributed in ways that suggest biological organization rather than random chemical processes. But here's where the story becomes more than just another astrobiology discovery. Here's where individual threads start weaving into a pattern that suggests something much larger is happening. The chemical composition of these leopard spots is precisely what you'd expect from ancient microbial communities. Vivianite and greigite, iron phosphate, and iron sulfide minerals that on Earth form almost exclusively through biological processes. These aren't just random chemical deposits. They're organized in spatial patterns that reflect the metabolic activity of living organisms. The timing matters crucially. This analysis was completed and published just weeks before 3I ATLAS reaches its closest approach to Mars. After sitting in peer review for over a year, after months of additional analysis and institutional debate, the paper appears exactly when the scientific community's attention is focused on Mars and the possibility of detecting non-terrestrial intelligence. If you believe in coincidences, this timing is merely fortunate. If you look for patterns, this timing suggests coordination. Consider the implications if 3I ATLAS is indeed artificial technology, as the accumulated evidence suggests. An interstellar probe conducting a survey of our solar system would certainly prioritize planets showing signs of biological activity. Mars, with its ancient lake systems, seasonal atmospheric changes, and subsurface water reserves, would be a primary target for detailed study. The leopard-spotted rocks represent evidence that Mars once hosted microbial life, probably not complex organisms, but living systems capable of metabolism, reproduction, and evolutionary adaptation. Life that existed billions of years ago when Mars had liquid water on its surface and atmospheric conditions suitable for biological processes. But what if that ancient life wasn't entirely extinct? What if some forms of Martian biology survived in subsurface environments, protected from radiation and temperature extremes by kilometers of rock and ice? What if Mars still hosts living systems that an advanced interstellar probe might be capable of detecting and analyzing? The forward-facing emissions from 3I ATLAS, which we discussed earlier as evidence for active protective systems, might serve dual purposes: protection from impact damage during interstellar travel, but also active sensing and analysis of planetary environments during close approach. At 18 million miles from Mars, 3I ATLAS will be well within range for advanced sensors to conduct detailed atmospheric analysis, subsurface scanning, and detection of biological or chemical signatures that our current technology can barely glimpse. If 3I ATLAS carries instruments comparable to our most sophisticated space-based sensors, but scaled up by factors representing centuries or millennia of technological advancement beyond our current capabilities, it could be conducting analyses of Mars that would take our rovers and orbiters decades to accomplish. The trajectory precision we analyzed earlier supports this interpretation. 3. Anomalies isn't just passing randomly through our solar system. Its path is optimized for detailed observation of planetary bodies showing signs of past or present biological activity. The timing also coordinates with seasonal variations on Mars. October 2025 corresponds to late southern hemisphere spring on Mars, when atmospheric conditions are optimal for detailed spectroscopic analysis and dust storm activity is minimal. If you were planning a detailed survey of Mars from an interstellar probe, you would time your closest approach for exactly these conditions. The chemical anomalies in 3I Atlas, the nickel without iron signature that violates natural stellar chemistry, might reflect material science advances that enable construction of sensors and instruments with capabilities we can't achieve using naturally occurring material combinations. Advanced civilizations capable of interstellar travel would certainly have developed materials with properties optimized for specific technological applications. Pure nickel alloys might be essential for sensor systems, communication equipment, or computational components that need to function reliably across the temperature and radiation extremes of interstellar space. The absence of iron, which we identified as chemically impossible for natural objects, makes perfect sense for engineered systems designed to avoid magnetic interference, oxidation, or other chemical processes that could compromise sensitive instrumentation. From this perspective, the spectroscopic signature of 3I Atlas isn't just evidence of artificial construction. It's evidence of advanced materials science applied to interstellar exploration technology. The mass calculations also support the survey hypothesis. 33 billion tons is enormous for a natural interstellar object, but reasonable for a comprehensive scientific mission. That mass could include advanced propulsion systems, long-term life support, extensive sensor arrays, sample collection and analysis equipment, and communication systems capable of transmitting data across interstellar distances. If 3I Atlas is conducting a systematic survey of our solar system, it would need equipment and resources proportional to the scope of that mission. A quick flyby could be accomplished with much less mass, but detailed study of multiple planetary bodies requires substantial infrastructure. The lack of non-gravitational acceleration, despite massive ongoing emissions, makes sense for a survey mission that needs to maintain precise trajectory control for optimal observation geometry. Active guidance systems would compensate for any unwanted forces, keeping the probe on its intended path regardless of asymmetric outgassing or solar radiation pressure. This also explains why the emissions are concentrated on the forward-facing side of the object. Instead of random sublimation, we might be seeing controlled venting from systems that need to maintain internal pressure, temperature, or chemical balance, while preserving trajectory accuracy. The scientific community's response to both the Mars life discovery and the 3I Atlas observations reveals institutional biases that extend beyond simple scientific conservatism. Both discoveries challenge fundamental assumptions about biological uniqueness and technological isolation that have shaped scientific thinking for centuries. The Mars life evidence was published after extensive peer review and institutional debate, precisely because the implications are so significant. Even potential biological signatures require extraordinary caution when they might represent the first confirmed evidence of life beyond Earth. But the timing of publication coinciding with 3I Atlas observations suggests that someone in the scientific establishment recognizes the potential connections between these discoveries. The possibility that we're witnessing not just one extraordinary coincidence, but a coordinated pattern of revelations about our place in a universe that contains both biological and technological intelligence beyond Earth. The data from both discoveries will be analyzed together in ways that individual studies cannot accomplish. Spectroscopic signatures, chemical compositions, temporal patterns, and geographical distributions will be cross-correlated to identify relationships that might not be apparent when examining each discovery in isolation. If 3i Atlas is indeed surveying Mars in response to detecting biological signatures, the high-resolution images we'll receive in 34 hours and 12 minutes might show modifications in the object's orientation or emission patterns that correlate with its approach to Mars. Active scanning, sensor deployment, or communication activities might be detectable as changes in the object's appearance or electromagnetic signature. Such activities would provide direct evidence of intelligent, purposeful behavior that natural objects cannot demonstrate. The convergence of Mars life evidence and interstellar visitor observations represents either the most extraordinary scientific coincidence in recorded history or the first coordinated revelation that we are not alone in the universe. In 34 hours, we begin to find out which interpretation matches reality. The same week that 3i Atlas approaches Mars, quantum computers achieved commercial viability on Wall Street. Artificial intelligence experienced its first major user revolt, and nuclear fusion sustained reactions for over 20 minutes. This isn't random timing. This is technological convergence on a scale that suggests preparation for something extraordinary. Let's start with quantum computing, because the implications extend far beyond financial trading algorithms. HSBC's 34% improvement in bond trading predictions using quantum processors represents a threshold crossing. Not just better performance, but fundamentally different computational capabilities applied to real-world problems with measurable economic impact. But quantum computing's relevance to potential contact scenarios goes deeper than financial applications. The same quantum processors that optimize trading algorithms can break cryptographic systems, simulate molecular interactions, and process information in ways that classical computers cannot match. If 3i Atlas is indeed artificial technology, if we're dealing with intelligence that has mastered interstellar travel, then communication protocols, data encryption, and information processing become critical considerations. Our current classical computer systems might be completely inadequate for interpreting or responding to technological communications from civilizations centuries or millennia more advanced than our own. Quantum computers operate on principles that might be universal rather than specific to human technology. Quantum entanglement, superposition, and computational complexity represent fundamental physics rather than engineering choices. An advanced civilization would likely have developed quantum information processing as a natural progression from classical computation. The timing of quantum computing's commercial breakthrough, coinciding with potential evidence of extraterrestrial technology, might reflect recognition within certain scientific and governmental circles that our computational infrastructure needs rapid advancement to handle unprecedented communication or analysis requirements. The artificial intelligence developments add another layer to this technological convergence. GPT-5's release and the subsequent user revolt reveal something crucial about the relationship between advanced AI systems and human acceptance of non-human intelligence. Users rejected GPT-5 not because it was less capable, but because it felt less human. The lobotomized characterization reflects discomfort with AI that demonstrates superior capabilities while lacking the personality traits that make interaction feel natural and comfortable. This reaction provides insights into how humanity might respond to contact with genuinely alien intelligence. If we struggle to accept artificial intelligence that we created ourselves, how will we react to intelligence that evolved independently under completely different conditions? The GPT-5 revolt might represent an early test case for human psychology's adaptation to non-human intelligence. The preference for less capable but more relatable AI suggests that successful contact protocols will need to account for human emotional and social needs, not just technical communication requirements. Nuclear fusion's 22-minute sustained reaction represents another threshold. Controlled fusion at this duration approaches practical energy generation timescales. While still far from commercial power plants, It demonstrates that the physics and engineering of fusion energy are transitioning from theoretical to practical. Fusion technology has obvious applications for interstellar travel. The energy densities required for meaningful interstellar propulsion likely require fusion or more advanced energy sources. If 3IATLS is artificial, its power systems probably represent centuries of advancement beyond our current fusion capabilities. But fusion technology also represents energy abundance that could transform human civilization within decades. Unlimited clean energy changes everything. Industrial processes, transportation, space exploration, computational capabilities, terraforming potential. The timing of fusion breakthrough coinciding with potential contact evidence might reflect preparation. Not conscious preparation by individual researchers, but systemic preparation by a scientific and technological infrastructure that somehow anticipates the need for advanced capabilities. The pattern extends beyond these three major developments. Biotechnology advances are accelerating treatment of previously incurable diseases. Materials science is producing substances with properties that seemed impossible decades ago. Space technology is achieving capabilities that enable detailed study of interstellar visitors. Each advancement individually represents normal scientific progress. But their convergence at this specific moment, when we may be encountering evidence of extraterrestrial technology, suggests coordination at a level beyond individual research programs or institutional planning. This coordination might reflect unconscious recognition within the scientific community that traditional timelines for technological development may be inadequate for challenges we haven't consciously acknowledged yet. If contact scenarios become reality, humanity will need quantum computing for secure communication and data analysis. We'll need advanced AI for translation, protocol development, and interface design. We'll need fusion energy for the industrial capabilities required to respond to technological civilizations operating at interstellar scales. The developments occurring in October 2025 provide exactly these capabilities, emerging at exactly the moment when they might become essential rather than merely useful. Consider also the geopolitical dimensions. China's quantum research, America's AI development, Europe's fusion projects, and international space cooperation all represent strategic investments in technologies that have obvious applications for contact scenarios. Nations are positioning themselves not just for economic competition but for technological leadership in areas that would become critically important if humanity confirms it's not alone in the universe. The space militarization trends, the international cooperation on Mars observations, and the rapid advancement of Earth-based technologies all point toward preparation for scenarios that extend beyond normal scientific or economic competition. Private companies are also participating in this convergence. SpaceX's rapid advancement of launch capabilities, quantum computing startups achieving commercial viability, AI companies pushing beyond current limitations. The private sector is investing in exactly the technologies that would be essential for contact scenarios. This might reflect market recognition of opportunities that haven't been publicly articulated yet. Investment patterns suggesting that sophisticated economic analysis is anticipating technology requirements for scenarios that remain officially speculative. The convergence also explains why certain breakthrough announcements receive muted media coverage despite their extraordinary significance. Quantum computing's commercial success, fusion duration records, and AI capability advances represent transformational achievements that would normally generate massive public attention. Instead, they're reported briefly and then overshadowed by political news, entertainment, and social media controversies. This pattern suggests either editorial decisions to downplay technological developments or systematic media direction that prioritizes distraction over technological awareness. If preparation for contact scenarios is occurring at institutional levels, maintaining public focus on routine political and social issues while advanced technological capabilities develop quietly would be a logical approach. The timing compression is also significant. These advances are occurring in weeks rather than years. Normal technological development follows longer timelines with gradual improvement spread across multiple research cycles. But breakthrough developments in quantum computing, AI, fusion, biotechnology, and space technology are all occurring simultaneously, suggesting either extraordinary coincidence or coordinated acceleration of research programs. In 32 hours and 7 minutes, we'll have high-resolution images of 3I Atlas that may reveal whether this technological convergence represents preparation for contact or simply remarkable timing. But regardless of what those images show, the pattern of simultaneous breakthrough developments represents a pivotal moment in human technological capability. We're crossing multiple thresholds simultaneously, achieving capabilities that position us to handle challenges we haven't officially acknowledged yet. The universe may be testing our readiness, and we may be passing that test faster than we realize. Behind the careful scientific language and international cooperation on 3I Atlas observations lies a geopolitical chess game that extends far beyond academic astronomy. When multiple space agencies suddenly coordinate billion-dollar spacecraft for observations that require complete mission replannings, when quantum computing breakthroughs coincide with potential contact evidence, when world powers quietly position themselves for scenarios that remain officially speculative, that reveal strategic thinking that goes far beyond what public statements acknowledge. China's participation in the coordinated Mars observations is particularly significant because it represents a departure from their typically independent space program approach. Chinese space missions usually operate autonomously, sharing minimal data with international partners and maintaining strict control over scientific findings and technological capabilities. But for the 3I Atlas observations, China's Tianwen-1 is participating in real-time coordination with American, European, and other international spacecraft. This cooperation requires sharing operational data, communication protocols, and potentially sensitive technical specifications about spacecraft capabilities. Such cooperation only occurs when the strategic implications outweigh normal competitive advantages, when the potential discoveries are significant enough that unilateral advantage becomes less important than coordinated response capability. This suggests that space agencies, despite their public caution about 3I Atlas, are privately treating it as a potential contact scenario rather than routine scientific observation. The quantum computing developments add another dimension to this strategic positioning. HSBC's breakthrough in financial trading demonstrates quantum advantage in pattern recognition and complex optimization, exactly the capabilities that would be essential for analyzing potential extraterrestrial communications or technology. Quantum computers can break existing encryption systems, but they can also create new forms of quantum cryptography that are theoretically unbreakable even by other quantum systems. If contact scenarios become reality, secure communication capabilities will become critically important for maintaining strategic advantage and controlling information flow. The fact that China leads in quantum satellite technology while the United States advances quantum computing hardware represents complementary capabilities that would be essential for different aspects of contact protocols. China's quantum satellites provide secure communication networks. American quantum processors provide computational analysis capabilities. Neither nation alone possesses complete quantum communication and computation infrastructure, but their combined capabilities would be sufficient for handling contact scenarios that require both secure networking and advanced data processing. The nuclear fusion breakthroughs also reflect strategic considerations beyond energy production. Fusion technology represents the minimum energy density requirements for meaningful interstellar travel. Any civilization capable of constructing objects, like 3I Atlas, certainly possesses fusion technology far beyond our current capabilities. But fusion also represents the industrial energy base required for constructing responses to contact scenarios. Whether those responses involve communication systems, space-based infrastructure, or defense capabilities, they would require energy production at scales that only fusion can provide practically. The timing of fusion duration records coinciding with potential contact evidence suggests that research priorities have been quietly adjusted to accelerate development of capabilities that might become strategically essential. Private industry participation in this technological convergence also reveals strategic thinking that extends beyond normal market forces. SpaceX's rapid advancement of heavy launch capabilities, quantum computing startups achieving commercial viability, AI companies pushing beyond current limitations. These investments represent enormous capital commitments in technologies that would be essential for contact scenarios. Venture capital and corporate research funding typically follow market demand and profit projections. But the current investment patterns suggest that sophisticated economic analysis is anticipating technology requirements for scenarios that remain officially speculative. This might reflect classified intelligence assessments that aren't reflected in public policy statements or academic research publications. If governmental or institutional analysis has concluded that contact scenarios have significant probability, private investment would naturally flow toward technologies that would become valuable under such conditions. The information control aspects are also revealing. Despite the extraordinary nature of 3I Atlas and its potential implications, mainstream media coverage has been minimal and carefully controlled. Science journalists who would normally pursue such stories aggressively have produced only brief technical reports that avoid speculation about broader implications. This pattern suggests either editorial direction that discourages extensive coverage of contact-related developments, or systematic media management that maintains public focus on routine political and social issues, while potentially transformational scientific developments occur quietly. The international cooperation on space observations contrasts sharply with increasing geopolitical tensions in other areas. While nations compete aggressively in economic, military, and diplomatic spheres, space agencies are coordinating efforts with unusual efficiency and minimal public attention. This suggests that space-related cooperation operates under different strategic guidelines than other international relations, possibly because space-based contact scenarios require coordinated response capabilities that transcend normal competitive advantages. The sample return competition adds another layer to these strategic considerations. China's aggressive Mars sample return timeline, NASA's struggling Mars sample return program, and European contributions to both efforts represent more than scientific competition. If Mars hosts current biological activity, if the ancient life evidence represents ongoing rather than extinct biology, then samples returned from Mars could provide technological advantages that extend far beyond academic research. Biological systems that evolved under Martian conditions might possess capabilities that Earth-based biotechnology could adapt for industrial, medical, or technological applications. The strategic value of accessing such capabilities first could justify enormous investment in sample return missions. The military implications are rarely discussed publicly, but they're certainly being analyzed privately. If 3I Atlas represents technology from a civilization capable of interstellar travel, then human military capabilities become irrelevant for any direct confrontation scenarios. But they remain relevant for maintaining social order during the psychological and social disruption that contact confirmation would produce. They also remain relevant for controlling access to contact-related technologies and ensuring that strategic advantages aren't distributed randomly among different nations or organizations. The space militarization trends that have accelerated over the past several years might reflect preparation for scenarios that extend beyond normal terrestrial strategic considerations. Space-based assets would be essential for communication, monitoring, and response coordination during contact scenarios. The establishment of Space Force branches in multiple nations, the development of anti-satellite capabilities, and the increasing military integration of space assets all suggest strategic planning for scenarios that require space-based operational capabilities. The economic implications are staggering and rarely acknowledged in public discourse. Contact confirmation would trigger economic disruption on scales that make historical market crashes seem minor. currency systems, international trade, technological development priorities, resource allocation. Everything would be affected by recognition that human civilization represents only one technological society among potentially many. The quantum computing, AI, and fusion developments might represent economic preparation for this disruption. Nations and organizations that possess advanced technological capabilities would maintain strategic advantages even during periods of economic reorganization. The timing coordination suggests that this preparation is not accidental. The simultaneous advancement of multiple strategic technologies during the same period when potential contact evidence emerges indicates planning at levels that transcend individual research programs or market forces. Whether this coordination reflects classified intelligence assessments, systematic strategic planning, or unconscious institutional recognition of emerging requirements, it demonstrates that the scientific and political establishment is positioning for scenarios that official public statements describe as highly speculative. In 30 hours and 23 minutes, high-resolution images of 3I Atlas will begin revealing whether these strategic preparations represent extraordinary foresight or unnecessary caution. But regardless of what those images show, the pattern of coordinated technological advancement and international cooperation represents a pivotal moment in human strategic capabilities. We're developing technologies and establishing coordination mechanisms that position us to handle challenges that extend far beyond current public awareness. The geopolitical chess game is already in motion. The pieces are positioned, the strategies are implemented. Now we wait to see what game we're actually playing. The most remarkable aspect of the 3I Atlas story isn't what's being reported. It's what isn't being reported. When an object that violates multiple fundamental principles of physics passes through our solar system, when Harvard astrophysicists assign it significant probability of being artificial technology, when space agencies coordinate unprecedented international observations, that should be front-page news worldwide. Instead, we get brief technical reports buried in science sections, minimal television coverage, and social media algorithms that somehow fail to amplify what should be the most discussed topic in human history. This silence isn't accidental. It's carefully orchestrated, systematically maintained, and revealing in ways that its architects probably didn't anticipate. Consider the baseline for comparison. When Oumuamua was discovered in 2017, despite being much less anomalous than 3I Atlas, it generated massive media coverage. Every major news organization produced multiple stories, social media discussion continued for months. Documentaries were produced, books were written. Oumuamua had unusual characteristics, but nothing approaching the accumulated anomalies of 3I Atlas. No impossible chemistry, no violation of fundamental physics, no trajectory precision that suggests intelligent guidance. Just an oddly shaped object with some unexplained acceleration. Yet Oumuamua became a cultural phenomenon while 3I Atlas, with far more extraordinary characteristics, passes through public consciousness with barely a whisper. The difference isn't the science. The difference is media management. Mainstream journalism operates under editorial guidelines that determine which stories receive extensive coverage and which are minimized or ignored entirely. These guidelines aren't necessarily explicit or coordinated, but they reflect institutional biases, advertising considerations, and relationships with government and corporate sources that shape coverage patterns. For stories involving potential extraterrestrial contact, additional factors influence editorial decisions: national security considerations, social stability concerns, economic disruption potential, and scientific establishment preferences all weigh against extensive public discussion of contact scenarios. The result is systematic underreporting of developments that could represent the most significant discoveries in human history. This underreporting serves multiple strategic purposes. It maintains public focus on routine political and social issues that don't threaten existing power structures or require fundamental changes in worldview. It prevents premature social and economic disruption while providing time for institutional preparation and response coordination. Most importantly, it allows controlled revelation of information at timing and in formats that serve strategic interests rather than public curiosity. The scientific establishment participates in this silent strategy through careful language, conservative conclusions, and emphasis on uncertainty rather than implications. Papers describing 3I Atlas use technical terminology that obscures significance for general audiences. Press releases emphasize caution and conventional explanations despite data that challenges those explanations. Individual scientists face career pressures that discourage speculation about extraordinary implications. Grant funding, promotion prospects, and professional reputation all depend on maintaining acceptability within conservative institutional boundaries. The result is scientific communication that's technically accurate but effectively misleading about the significance of discoveries that could reshape human understanding of our place in the universe. Academic journals contribute to this pattern through peer review processes that favor conventional interpretations and discourage conclusions that challenge fundamental assumptions. Papers suggesting artificial origin for astronomical objects face additional scrutiny, longer review periods, and higher rejection rates regardless of data quality. This doesn't reflect scientific conspiracy. It reflects institutional bias toward explanations that don't require paradigm shifts or challenge existing theoretical frameworks. But paradigm shifts are how science advances. The resistance to considering extraordinary explanations for extraordinary data represents institutional failure rather than scientific rigor. The technology sector's response reveals another dimension of the silent strategy. Companies that would normally capitalize on public interest in advanced technology, space exploration, and artificial intelligence have been remarkably quiet about developments that should align perfectly with their marketing interests. SpaceX, which regularly generates publicity about Mars colonization plans, hasn't prominently featured the potential discovery of interstellar technology that could revolutionize space travel concepts. AI companies that emphasize the revolutionary potential of their systems haven't connected their capabilities to the computational requirements for analyzing potential extraterrestrial communications. This restraint suggests either editorial coordination that discourages technology companies from amplifying contact-related stories, or strategic decisions that prioritize other considerations over normal marketing advantages. Social media platforms, which typically amplify controversial or extraordinary content for engagement purposes, seem to be suppressing rather than promoting discussion of 3I Atlas developments. Algorithms that normally push viral content somehow fail to recognize the viral potential of discoveries that should dominate public conversation. This selective algorithmic behavior suggests either systematic technical failure across multiple platforms simultaneously or intentional content management that prioritizes other information over potential contact evidence. Government communication strategies also contribute to the silence. Space agencies that regularly publicize routine missions and discoveries have produced minimal public statements about observations that could represent first contact scenarios. NASA, ESA, and other agencies that normally engage extensively with public outreach and education have maintained unusually low profiles regarding 3I Atlas observations and their potential implications. This restraint might reflect classified assessments that aren't reflected in public statements, or institutional policies that discourage speculation about scenarios that could trigger social or economic disruption. The international coordination of this silent strategy reveals sophisticated media management capabilities that transcend national boundaries and institutional limitations. When multiple countries, organizations, and industry sectors simultaneously minimize coverage of potentially transformational discoveries, that suggests coordination at levels that aren't reflected in official organizational structures. This coordination might operate through informal networks of institutional relationships, shared strategic assessments, or common recognition that premature revelation could produce social consequences that outweigh immediate scientific or commercial advantages. The effectiveness of the silent strategy demonstrates how information can be controlled in democratic societies without explicit censorship or government intervention. Market forces, institutional pressures, and social conformity create systematic biases that shape public awareness without requiring central coordination or authoritarian control. But silent strategies have limitations. They work effectively for controlling initial revelation and managing public response timing, but they become increasingly difficult to maintain as evidence accumulates and independent analysis expands. The scientific method includes self-correction mechanisms that eventually overcome institutional biases. Peer review, replication requirements, and competitive research ensure that significant discoveries eventually receive attention proportional to their importance. Social media, despite algorithmic management, provides platforms for independent researchers and citizen scientists to share analysis and conclusions that traditional media outlets minimize or ignore. The silent strategy may be reaching its sustainability limits. The coordination required to suppress discussion of evidence this extraordinary becomes increasingly obvious and counterproductive as more people recognize the pattern. In 28 hours and 41 minutes, high-resolution images of 3I Atlas will provide visual evidence that will be much harder to minimize or control than spectroscopic data and mathematical analysis. If those images reveal surface features that clearly indicate artificial construction, the silent strategy will face its ultimate test. Visual evidence of extraterrestrial technology will be impossible to dismiss through technical language or institutional caution. The choice will become binary. Acknowledge the extraordinary nature of the discovery, or maintain silent strategies that become increasingly transparent and ultimately self-defeating. Public awareness is growing despite systematic underreporting. Independent researchers are analyzing data and sharing conclusions through channels that bypass traditional media gatekeepers. Scientific integrity is creating pressure for honest assessment of evidence, regardless of institutional preferences. The silent strategy represents a delaying tactic rather than a permanent solution. It provides time for institutional preparation and coordination, but it cannot indefinitely suppress evidence that challenges fundamental assumptions about human uniqueness in the universe. We may be witnessing the final phase of this strategy, the moment when accumulated evidence overwhelms institutional capacity for control and management. When the truth becomes too obvious for silence to remain sustainable, 28 hours and 37 minutes until that moment arrives. The scientific establishment's response to 3I Atlas reveals institutional biases that extend far beyond normal academic conservatism. When faced with data that challenges fundamental assumptions about our place in the universe, the same community that claims to value evidence-based reasoning and paradigm-shifting discoveries becomes remarkably resistant to conclusions that their own data supports. This resistance operates through mechanisms that are subtle but systematic, creating barriers to research that explores extraordinary explanations for extraordinary evidence. Academic career structures provide the foundation for this resistance. Graduate students, postdoctoral researchers, and faculty members seeking tenure face intense pressure to produce research that aligns with established theoretical frameworks and institutional expectations. Publications suggesting artificial origin for astronomical objects face additional scrutiny during peer review, longer publication timelines, and higher rejection rates regardless of data quality or analytical rigor. Researchers who pursue such topics find themselves marginalized within professional communities, excluded from collaboration networks and disadvantaged in competition for grants and positions. The result is systematic selection pressure against research that explores hypotheses challenging to institutional orthodoxy. Graduate advisors routinely discourage students from pursuing thesis topics that involve potential extraterrestrial technology, not because the science is flawed, but because such topics are perceived as career-limiting. Even exceptional research demonstrating compelling evidence for artificial origin struggles to secure academic positions for its authors. This creates intellectual conformity through economic pressure rather than scientific reasoning. Conference programming reflects these biases through session organization that segregates unconventional research into specialized sessions with minimal attendance, while mainstream research receives prominent placement and extensive discussion. Presentations discussing potential artificial origin for objects like 3I Atlas are typically scheduled during peripheral time slots, reviewed by committees with predetermined skepticism, and discussed in contexts that emphasize criticism rather than constructive analysis. The message is clear: such research is tolerated but not encouraged, acknowledged but not supported. Grant funding agencies compound these pressures through review processes that favor conventional research proposals over investigations that might challenge existing paradigms. Proposals exploring potential extraterrestrial technology face reviewer panels predisposed towards skepticism, evaluation criteria that emphasize conventional feasibility over innovative potential, and funding algorithms that effectively discriminate against unconventional hypotheses. Even researchers with established records of excellence find funding difficult to secure for projects that venture beyond acceptable boundaries of speculation. This systematic funding bias ensures that most research exploring extraordinary explanations for extraordinary data remains underfunded, understaffed, and unable to compete with well-supported conventional research programs. Professional societies contribute through membership standards, publication policies, and official position statements that discourage speculation about extraterrestrial technology while promoting conventional explanations regardless of evidence quality. The American Astronomical Society, International Astronomical Union, and other professional organizations maintain official neutrality regarding potential extraterrestrial contact, but their practical policies consistently favor conventional interpretations and discourage research suggesting artificial origin for astronomical phenomena. These policies operate through informal pressure rather than explicit prohibition, creating environments where researchers self-censor rather than risk professional consequences. Media relationships between scientific institutions and journalists also shape public perception of discoveries like 3I Atlas. Scientists receive training in communication that emphasizes caution, uncertainty, and conventional explanations when discussing potentially controversial findings. Press releases describing 3I Atlas consistently emphasize natural explanations, despite data that challenges those explanations. Interviews with researchers focus on limitations and uncertainties rather than implications and significance. The result is public communication that's technically accurate but effectively misleading about the strength of evidence supporting extraordinary conclusions. International scientific cooperation reflects similar biases through collaborative agreements that prioritize conventional research objectives over investigation of potentially transformational discoveries. Space agencies coordinate observations of 3I Atlas through frameworks that emphasize routine scientific return rather than contact scenario possibilities. Research partnerships focus on conventional data analysis rather than exploration of implications that could challenge existing theoretical foundations. This cooperation serves scientific purposes while avoiding acknowledgement of possibilities that could revolutionize human understanding of our cosmic context. Historical precedents demonstrate that scientific establishments routinely resist paradigm-shifting discoveries until evidence becomes overwhelming and resistance becomes professionally unsustainable. Continental drift, bacterial causes of ulcers, heliocentrism, quantum mechanics, and numerous other revolutionary concepts faced institutional resistance that delayed acceptance by decades despite compelling supporting evidence. The resistance to considering artificial explanations for objects like 3I Atlas follows identical patterns, dismissing extraordinary evidence, emphasizing alternative explanations regardless of plausibility, and creating professional consequences for researchers who pursue unconventional hypotheses. But resistance strategies that worked effectively when communication was limited and research was centralized face challenges in contemporary information environments where independent analysis and citizen science can evaluate evidence without institutional approval. Social media platforms, online collaboration tools, and accessible data analysis software enable researchers to share findings and coordinate investigations outside traditional academic structures. Independent researchers with relevant expertise can analyze the same data available to institutional scientists and reach conclusions that professional constraints prevent academic researchers from pursuing publicly. This creates parallel research communities that aren't subject to the institutional pressures that limit academic investigation of extraordinary phenomena. Private funding sources also provide alternatives to traditional grant agencies that may be more willing to support unconventional research. Technology entrepreneurs, private foundations, and crowdfunding platforms can support investigation of potential extraterrestrial technology without the institutional biases that affect government funding. These alternative funding mechanisms enable research programs that might be impossible within traditional academic structures. The effectiveness of establishment resistance depends ultimately on evidence quality and public awareness. While institutional pressure can suppress investigation and discussion of extraordinary hypotheses, it cannot alter underlying physical reality or prevent accumulation of compelling evidence. 3. Atlas presents evidence that challenges conventional explanations across multiple independent lines of analysis. Mass calculations, chemical signatures, trajectory precision, emission patterns, and energy requirements all point toward conclusions that institutional orthodoxy prefers to avoid. But scientific integrity requires honest assessment of evidence regardless of implications. The fundamental principles of scientific method include willingness to revise theoretical frameworks when evidence demands paradigm shifts. In 26 hours and 15 minutes, high-resolution images will provide visual evidence that may be impossible to dismiss through conventional resistance mechanisms. If those images reveal surface features that clearly indicate artificial construction, institutional resistance will face unprecedented challenges. Visual evidence of extraterrestrial technology would be accessible to general audiences without requiring specialized expertise to interpret. Public pressure for honest scientific assessment would become difficult to resist through traditional institutional mechanisms. The scientific establishment's response to such revelations will determine whether professional science maintains credibility during paradigm shifts that challenge fundamental assumptions about human uniqueness in the universe. History suggests that institutions that resist overwhelming evidence eventually lose scientific authority to research communities that demonstrate greater intellectual honesty and analytical rigor. The choice facing the scientific establishment is whether to lead paradigm shifts or be dragged along by evidence that becomes too obvious to ignore. 26 hours and 11 minutes until that choice becomes unavoidable. The high-resolution images captured in 24 hours and 7 minutes will trigger response protocols that have been decades in development, but never officially acknowledged, regardless of what those images reveal. October 3rd, 2025 marks a threshold in human civilization that we cannot step back from. If the images show natural features, irregular surfaces, impact craters, and compositional variations consistent with formation through random accretion and collision processes, then 3I Atlas joins the category of extraordinarily unusual but ultimately natural objects. But even this scenario represents a profound expansion of our understanding of what natural processes can produce. An object that violates stellar chemistry, demonstrates impossible mass concentrations, and maintains trajectory precision through unknown physical mechanisms would require theoretical frameworks that don't currently exist. Natural explanations for the accumulated anomalies would demand revolutionary advances in astrophysics, planetary science, and interstellar chemistry. The implications would ripple through multiple scientific disciplines, challenging assumptions about stellar nucleosynthesis, planetary formation, and interstellar object evolution. Career opportunities would emerge for researchers willing to tackle theoretical problems that conventional frameworks cannot address. Funding would flow toward investigations that previously seemed too speculative for serious consideration. the scientific establishment would face pressures to acknowledge that our current understanding of cosmic processes is far more limited than institutional confidence has suggested. But if the images reveal geometric patterns, regular structures, or surface features that indicate intelligent design and construction, then everything changes in ways that no response protocol can fully prepare for. First contact protocols exist in multiple space agencies, government departments, and international organizations. These protocols address communication procedures, information sharing agreements, and coordination mechanisms for scenarios involving detection of extraterrestrial intelligence. But existing protocols assume contact through radio signals, electromagnetic communications, or other remote interaction methods. They don't adequately address contact through physical visitation by objects passing through our solar system. The legal frameworks are particularly problematic. International law governing space activities was developed for human space exploration and doesn't address jurisdictional questions involving extraterrestrial technology or artifacts. Which nation or organization has authority to study, communicate with, or respond to interstellar visitors? How are discoveries shared between countries with competing strategic interests? What happens if different nations reach conflicting conclusions about the nature or intentions of extraterrestrial technology? These questions have no established answers, creating potential for international conflicts that could overshadow the scientific significance of contact confirmation. Military implications would trigger classified response protocols that the public won't see but will certainly feel through policy changes, resource allocations, and strategic adjustments. Defense establishments worldwide have contingency plans for exotic threat scenarios, but those plans were developed around assumptions about technological capabilities that interstellar travel would far exceed. Military responses would focus on intelligence gathering, threat assessment, and strategic positioning, rather than direct confrontation with technology that represents capabilities centuries or millennia beyond current human achievement. But military involvement would inevitably militarize what should be scientific and diplomatic processes, potentially compromising opportunities for constructive contact through aggressive or defensive responses. Economic implications would unfold across multiple timescales and sectors. Immediate market reactions to contact confirmation would likely produce significant volatility as investors attempt to assess which industries, currencies, and technologies would gain or lose value in a universe confirmed to contain multiple technological civilizations. Longer-term economic impacts would depend on whether contact remains limited to observation and study or develops into communication and potential technology transfer. Even limited contact would trigger massive investment in space technology, communication systems, and research infrastructure. Universities, aerospace companies, and technology firms would compete for government contracts and private investment in contact-related capabilities. Scientific instrument manufacturers, data analysis companies, and space launch providers would experience demand surges that current industrial capacity couldn't support. Social and psychological responses would vary enormously across different populations, cultures, and belief systems. Religious communities would face theological questions about the significance of non-human intelligence in cosmic contexts. Some religious frameworks accommodate multiple intelligent species easily, while others would require fundamental reinterpretation of doctrines that assume human uniqueness in divine creation. Educational systems would need curriculum updates to incorporate accurate information about cosmic contexts that include multiple technological civilizations. Science textbooks, history courses, and philosophy classes would require content adjustments to reflect expanded understanding of intelligence, technology, and biological evolution. Media coverage would intensify dramatically once visual evidence becomes available. The silent strategies that currently minimize discussion of three-eye atlas would become unsustainable when confronted with images that clearly indicate artificial construction. Television networks, internet platforms, and social media would generate continuous coverage and analysis, as experts and commentators attempt to interpret the implications of confirmed contact evidence. This coverage would probably include significant misinformation, speculation, and sensationalism as media outlets compete for audiences during unprecedented historical developments. Scientific research priorities would undergo complete reorganization as funding flows toward contact-related investigations. Projects exploring communication protocols, interstellar technology analysis, and extraterrestrial intelligence research would receive unprecedented support. Universities would establish new departments and research centers focused on contact studies. Academic positions would emerge in fields that currently don't exist. Graduate programs would be developed to train specialists in areas where no expertise currently exists. The research questions would be extraordinary. How do we decode potential communications from civilizations with completely different technological development histories? How do we analyze materials and engineering approaches that represent centuries of advancement beyond our current capabilities? International cooperation would become essential for managing contact scenarios effectively, but geopolitical competition would complicate coordination efforts. The United Nations would likely establish specialized committees or agencies to coordinate international responses, but enforcement mechanisms for contact-related agreements remain undefined. Space law would require rapid development to address questions about artifact recovery, technology sharing, and response protocols that current treaties don't cover. The timeline for these developments depends on what the October 3rd images reveal, but institutional preparation is already underway through the technological convergence we've discussed. Quantum computing capabilities, artificial intelligence advances, fusion energy development, and international space cooperation all represent infrastructure that would be essential for managing contact scenarios effectively. The coordination of these technological advances with potential contact evidence suggests that response planning operates at levels that transcend official government policies or academic research programs. Whether this coordination reflects classified intelligence assessments, strategic planning based on scientific analysis, or unconscious institutional preparation, it demonstrates that human civilization is developing capabilities that would be essential for constructive contact scenarios. Private sector preparation is also evident through investment patterns that anticipate technology requirements for scenarios that remain officially speculative. Companies developing advanced communication systems, space-based infrastructure, and artificial intelligence capabilities are positioning themselves for markets that could emerge rapidly if contact scenarios develop. The signs of preparation extend beyond technology into social and cultural domains. Science fiction, popular media, and educational content have gradually shifted toward more realistic depictions of contact scenarios, potentially preparing public consciousness for revelations that would have seemed inconceivable decades earlier. Public opinion polling shows increasing acceptance of extraterrestrial intelligence possibilities, suggesting that contact confirmation might produce less social disruption than historical assessments predicted. The next 72 hours will reveal whether these preparations represent extraordinary foresight or unnecessary caution. But regardless of the October 3rd discoveries, human civilization has already crossed thresholds that position us for scenarios that extend far beyond our current official planning. We've developed technologies that could enable contact communication. We've established international coordination mechanisms that could manage contact protocols. We've created social and cultural contexts that could accommodate contact confirmation. 24 hours and 3 minutes from now, we begin to learn whether these capabilities are merely interesting technological achievements or essential infrastructure for the next phase of human development in a universe that contains intelligence, technology, and purposes that extend far beyond our current understanding. The preparation is complete. The moment approaches. History waits to see which version of the future we'll be writing. 3. IATLAS is not an isolated phenomenon. It's a data point in a pattern that extends across multiple scientific disciplines, technological developments, and social changes that collectively suggest humanity is approaching a transition point whose significance we're only beginning to recognize. The convergence isn't random. The timing isn't coincidental. The scale isn't accidental. We're witnessing the emergence of capabilities and circumstances that position human civilization for scenarios that transcend our current understanding of what's possible, what's likely, and what we should be preparing for. Consider the broader timeline of developments that have accelerated over the past several years. Breakthrough discoveries in astronomy that reveal the universe contains far more complexity, organization, and potential for life than previous models predicted. Exoplanet discoveries showing that planetary systems are common, that Earth-like worlds exist throughout the galaxy, and that the chemical conditions necessary for life occur frequently in cosmic environments. Astrobiology advances demonstrating that life can survive in conditions previously thought impossible, suggesting that biological evolution is more robust and adaptive than Earth-based experience indicated. These discoveries systematically expand the probability estimates for extraterrestrial life and intelligence, shifting scientific consensus from skepticism toward recognition that biological and technological intelligence probably exists throughout the galaxy. Simultaneously, human technological capabilities are advancing along trajectories that align precisely with the requirements for detecting, analyzing, and potentially responding to evidence of extraterrestrial intelligence. Quantum computing provides computational capabilities that could decrypt alien communications or analyze technology beyond current understanding. Artificial intelligence offers translation, pattern recognition, and analysis capabilities that could interpret contact evidence. Fusion energy supplies the industrial capacity needed for space-based response infrastructure. The coordination of these technological advances with expanded probability estimates for extraterrestrial intelligence creates conditions where contact scenarios transition from speculation to practical planning considerations. But the pattern extends beyond scientific and technological developments into social, economic, and cultural changes that suggest broader preparation for paradigm shifts that would accompany contact confirmation. Media representation of extraterrestrial intelligence has evolved from sensationalism toward realistic consideration of contact scenarios and their implications. Educational content increasingly incorporates accurate scientific information about astrobiology, exoplanets, and the probability of extraterrestrial life. Public opinion surveys show growing acceptance of extraterrestrial intelligence possibilities, declining religious objections to non-human intelligence, and increasing support for space exploration and contact research. These cultural shifts create social contexts that could accommodate contact confirmation with less disruption than historical assessments predicted. Economic structures are also adapting in ways that anticipate scenarios requiring rapid technological advancement and resource reallocation. Private investment in space technology, communication systems, and artificial intelligence reflects market recognition of opportunities that could emerge rapidly under contact scenarios. Government funding priorities show similar anticipation through increased support for space exploration, advanced technology research, and international cooperation programs that would be essential for managing contact situations effectively. International relations demonstrate preparation through space cooperation agreements that transcend normal geopolitical competition, coordinated response protocols for exotic scenarios, and diplomatic frameworks that could accommodate contact management requirements. The institutional preparation extends into classified domains that public analysis cannot access directly, but whose effects are visible through policy changes, resource allocations, and strategic adjustments that suggest planning for scenarios that remain officially speculative. Military space programs, intelligence community priorities, and defense research investments all show patterns consistent with preparation for contact scenarios that would require capabilities beyond normal terrestrial strategic requirements. The convergence of scientific discoveries, technological capabilities, social adaptation, economic preparation, and institutional planning creates conditions where contact scenarios become manageable rather than catastrophic. This preparation might reflect conscious strategic planning based on classified intelligence assessments that anticipate contact probabilities higher than public statements acknowledge. Alternatively, it might represent unconscious institutional adaptation as multiple systems simultaneously recognize changing circumstances and adjust their operations accordingly. But conscious or unconscious, the preparation demonstrates that human civilization is developing the infrastructure, capabilities, and social frameworks that would be necessary for constructive contact scenarios. 3. Atlas arrives at exactly the moment when these preparations reach sufficient maturity to handle the implications of potential contact evidence. The timing suggests either extraordinary coincidence or coordination at levels that transcend individual institutional planning and market forces. The scale of coordination required to synchronize scientific discoveries, technological breakthroughs, social adaptation, and institutional preparation across multiple countries, organizations, and sectors suggests either remarkable emergent behavior or systematic orchestration. Historical precedents for such large-scale coordination are rare and typically associated with major transformational events, world wars, economic depressions, technological revolutions that reshape civilization fundamentally. The current coordination might reflect recognition that contact scenarios represent transformation potential comparable to these historical precedents. If extraterrestrial intelligence exists and has capabilities to travel between star systems, then contact represents the most significant development in human history. More significant than agriculture, written language, industrial revolution, or any other transformational development. The preparation we're observing might reflect appropriate responses to transformation potential of this magnitude. The implications extend beyond contact scenarios into broader questions about human development, technological evolution, and our role in cosmic contexts that might include multiple technological civilizations. If we are not alone, if intelligence and technology are common features of cosmic evolution, then humanity represents one participant in a universe-wide community of technological species. Our development trajectory, our technological choices, and our social evolution might be influenced by or evaluated against standards that reflect this broader cosmic context, rather than purely terrestrial considerations. The current acceleration of human capabilities might reflect preparation for participation in cosmic civilization, rather than simply internal technological and social development. This perspective explains why current developments seem to anticipate requirements for scenarios that extend beyond normal terrestrial planning horizons. We might be approaching the threshold where human civilization transitions from planetary isolation to cosmic participation. The next 22 hours will provide evidence about whether this transition is imminent or remains theoretical. But regardless of what the October 3rd images reveal, the pattern of preparation demonstrates that human civilization is developing capabilities that position us for scenarios that transcend our current understanding of what's possible. We're not just building better technology, developing better science, or creating better social institutions. We're building the foundation for human participation in contexts that extend far beyond Earth, far beyond our current understanding of intelligence and technology, and far beyond our current conception of what it means to be human, in a universe that might contain intelligence and purpose at scales we're only beginning to imagine. 3i Atlas might be the signal that this transition is beginning, the evidence that our preparation has been appropriate, the confirmation that the universe contains the intelligence, technology, and opportunities that our development trajectory has been anticipating. Or it might be an extraordinarily unusual natural object that tests our readiness for scenarios that remain theoretical. Either way, we've demonstrated that human civilization can develop the capabilities needed to handle contact scenarios constructively. We've shown that we can coordinate internationally, advance technologically, and adapt socially for challenges that extend beyond our previous experience. We're ready for whatever the universe is about to tell us. 21 hours and 54 minutes until we find out what that is. You are not a passive observer of these developments. You are a participant in what may be the most significant moment in human history, And your awareness, your questions, and your engagement matter more than you might realize. The traditional model of scientific discovery assumes that breakthroughs happen in laboratories and institutions, get published in academic journals, and eventually filter down to public awareness through media coverage and educational systems. But we're living through developments that transcend this traditional model. The evidence surrounding 3I Atlas, the technological convergence we've discussed, and the institutional preparations occurring across multiple sectors create conditions where informed citizen participation becomes essential rather than optional. You have access to the same data that professional researchers are analyzing. Spectroscopic observations, trajectory calculations, mass estimates, and chemical analysis results are publicly available through NASA databases, ESA archives, and international astronomical repositories. The tools for analyzing this data are increasingly accessible. Software packages that were once restricted to professional researchers are now available as free downloads. Online courses teach data analysis techniques that enable independent verification of official conclusions. Most importantly, you can think about the implications without the institutional constraints that limit academic researchers' ability to pursue unconventional hypotheses or discuss extraordinary possibilities. Your questions don't need to fit within grant funding guidelines or tenure review criteria. Your analysis doesn't need to satisfy peer review committees that may be biased toward conventional explanations. Your conclusions don't need to preserve professional relationships or maintain institutional credibility. This intellectual freedom creates opportunities for insights that constrained professional analysis might miss. Citizen science has already produced significant contributions to astronomy, biology, physics, and other fields where large datasets require analysis capabilities that exceed institutional resources. Projects like Galaxy Zoo, SETI at Home, and Folding at Home demonstrate that distributed citizen participation can achieve research results that would be impossible through traditional academic approaches alone. The 3I Atlas situation represents an ideal case for citizen science contributions. The data is complex enough to benefit from multiple analytical perspectives. The implications are significant enough to justify extensive volunteer effort, and the institutional constraints are strong enough that academic research may miss important patterns or conclusions. Your participation could take multiple forms depending on your interests, skills, and available time. Data analysis represents the most direct contribution possibility. Download observation datasets, learn to use astronomical analysis software, and conduct independent verification of official conclusions about 3I ATLA's characteristics. Look for patterns that institutional analysis might have missed. Test alternative explanations for anomalous observations. Calculate probability estimates using different assumptions than official assessments employ. Even if your analysis confirms official conclusions, independent verification strengthens confidence in results that challenge conventional understanding. Pattern recognition offers another contribution opportunity. The coordination between 3I ATLS observations, technological breakthroughs, and institutional preparations creates a complex web of relationships that may be difficult for specialists focused on individual domains to recognize fully. Your broader perspective, unconstrained by disciplinary boundaries, might identify connections that narrow professional focus overlooks. Document timeline correlations between different developments. Research funding patterns that anticipate technology requirements for contact scenarios. Policy changes that suggest preparation for extraordinary circumstances. Information sharing enables coordination between citizen researchers that can accomplish analysis projects beyond individual capabilities. Social media platforms, online forums, and collaborative tools provide infrastructure for organizing citizen science efforts focused on 3I ATLS and related developments. Share interesting data discoveries, discuss analytical techniques, coordinate verification efforts, and build research communities that operate independently of institutional constraints, but maintain high standards for evidence quality and analytical rigor. Citizen science contributions are most valuable when they meet or exceed professional research standards rather than simply providing alternative opinions. Public awareness and education represent perhaps the most important contributions you can make. The silent strategies we discussed earlier depend on public indifference and distraction from developments that could reshape human understanding of our cosmic context. Your engagement with these topics, your discussions with friends and family, and your social media activity help determine whether extraordinary scientific developments receive attention proportional to their significance. Ask questions about why potential contact evidence receives minimal media coverage while routine political controversies dominate public attention. Research the scientific evidence behind 3I Atlas anomalies and share your findings with others who might not encounter this information through mainstream sources. Support researchers, journalists, and content creators who provide honest analysis of extraordinary developments despite institutional pressures that discourage such coverage. Your attention and engagement provide the social validation that enables continued investigation of topics that institutional constraints tend to suppress. Economic participation offers another avenue for supporting developments that transcend normal market forces. Invest in companies developing technologies that would be essential for contact scenarios. Space technology, quantum computing, artificial intelligence, advanced communication systems. Support crowdfunding projects that enable independent research on topics that traditional funding sources avoid. Purchase products and services from organizations that demonstrate intellectual honesty about extraordinary scientific developments rather than organizations that participate in silent strategies. Your economic choices provide signals that influence whether markets anticipate and prepare for scenarios that extend beyond conventional business planning. Historical awareness provides context for understanding the significance of current developments and your role in processes that may reshape human civilization fundamentally. Previous paradigm shifts in human understanding, the Copernican revolution, Darwin's theory of evolution, quantum mechanics, DNA structure, all faced institutional resistance before overwhelming evidence forced acceptance. Individual scientists, researchers, and citizens who supported these paradigm shifts despite professional and social pressure played essential roles in advancing human knowledge and capability. Your willingness to engage with evidence that challenges conventional assumptions continues this tradition of intellectual courage that enables scientific and social progress. The next 19 hours and 43 minutes will provide visual evidence that may definitively establish whether 3I represents natural phenomena or artificial technology. But regardless of what those images reveal, your informed engagement with these developments contributes to human civilization's capacity for handling extraordinary discoveries constructively. You are participating in processes that extend far beyond individual curiosity or entertainment. You are contributing to humanity's intellectual and cultural preparation for scenarios that could represent the most significant development in our species' history. Your questions, your analysis, your discussions, and your engagement help determine whether human civilization responds to extraordinary evidence with wisdom, caution, and constructive preparation, or with denial, distraction, and institutional paralysis. The universe may be about to provide answers to questions that humanity has wondered about for millennia. Whether we're alone, whether intelligence and technology exist beyond Earth, whether contact with other civilizations is possible, your role in receiving and responding to those answers matters. Your intellectual preparation, your analytical capabilities, and your commitment to evidence-based reasoning contribute to outcomes that affect not just your own understanding, but human civilization's trajectory and contexts that extend far beyond our current experience. History is written by people who engage with extraordinary circumstances rather than people who ignore them. The most extraordinary circumstances in human history may be unfolding right now. Your participation matters. 19 hours and 37 minutes to find out how much. Section 16. The truth is coming. 1,800 words. The countdown ends in 18 hours and 52 minutes. At that moment, Cameras orbiting Mars will capture images that answer questions humanity has pondered since we first looked up at the stars and wondered if we were alone. But the truth isn't waiting for October 3rd to reveal itself. The truth is already here, embedded in data that challenges everything we thought we knew about physics, chemistry, and our place in the universe. The truth is in mathematics that show 3I Atlas shouldn't exist if natural processes follow the rules we've established through centuries of observation and analysis. The truth is in spectroscopic signatures that violate basic stellar chemistry in ways that suggest materials processing capabilities beyond anything random natural events can achieve. The truth is in trajectory precision that requires guidance systems operating over interstellar distances and cosmic timescales with accuracy that natural ejection events cannot provide. The truth is in emission patterns that contradict fundamental comet physics while demonstrating energy expenditure and directional control that passive objects cannot generate. The truth is in timing that coordinates potential first contact evidence with technological breakthroughs that would be essential for managing contact scenarios constructively. The truth is in institutional responses that reveal preparation for extraordinary circumstances despite official statements that emphasize conventional explanations and minimize extraordinary implications. You don't need to wait for October 3rd images to recognize that the evidence already points toward conclusions that challenge our most fundamental assumptions about intelligence, technology, and cosmic context. The images will provide visual confirmation of what mathematical analysis, chemical signatures, and physical behavior have already established. They will either show natural features that somehow produced impossible natural phenomena, or artificial features that confirm what the data has been indicating. But the broader truth extends beyond any single object or observation. The truth is that human civilization is experiencing convergent developments across multiple domains that collectively suggest we're approaching a transition point whose significance extends far beyond normal scientific or technological progress. We're not just discovering unusual objects in space. We're developing capabilities that enable recognition and analysis of artificial technology from other civilizations. We're not just advancing quantum computing, artificial intelligence, and fusion energy independently. We're coordinating technological development that would be essential for contact scenarios. We're not just improving international cooperation on space exploration. We're establishing frameworks that could manage first contact protocols effectively. The pattern reveals preparation for scenarios that remain officially speculative but practically anticipated through resource allocation, research priorities, and institutional planning that transcends normal market forces or academic interests. This preparation might reflect classified intelligence assessments that conclude contact scenarios have significant probability. It might reflect unconscious institutional adaptation as multiple systems recognize changing circumstances and adjust accordingly. But conscious or unconscious, the preparation demonstrates that human civilization is developing infrastructure, capabilities, and coordination mechanisms that would be necessary for constructive engagement with evidence of extraterrestrial intelligence. The timing of this preparation, coinciding with potential contact evidence from 3I Atlas, suggests either remarkable coincidence or coordination at levels that indicate contact scenarios are transitioning from theoretical possibility to practical planning consideration. The truth that's coming on October the 3rd of May simply confirm what careful analysis of existing evidence already indicates. We are not alone in the universe. Intelligence and technology exist beyond Earth. Other civilizations have achieved interstellar travel capabilities. Contact is not a question of if, but when and how. But even if the images reveal natural explanations for 3I Atlas anomalies, the broader pattern of technological convergence, institutional preparation, and scientific discovery acceleration suggests that contact scenarios remain highly probable in timeframes measured in years rather than centuries. The search for extraterrestrial intelligence has detected signals that don't fit natural explanations. Astrobiology research continues identifying environments where life could exist beyond Earth. Exoplanet discoveries reveal Earth-like worlds throughout the galaxy. Each development increases the probability that we will encounter evidence of extraterrestrial intelligence through multiple pathways rather than depending on any single discovery or contact method. Your role in these developments extends beyond passive observation into active participation in processes that could reshape human understanding of intelligence, technology, and cosmic context fundamentally. The questions you ask, the research you conduct, the discussions you engage in, and the attention you provide to extraordinary developments all contribute to human civilization's capacity for handling contact scenarios constructively. Independent analysis of 3I Atlas data could reveal patterns that institutional constraints prevent professional researchers from pursuing publicly. Citizen science contributions could verify official conclusions or identify alternative explanations that merit further investigation. Public engagement could ensure that extraordinary scientific developments receive attention proportional to their significance, rather than being minimized through media management strategies. Social and economic participation could support continued research and technological development that prepares human civilization for contact scenarios regardless of when they occur. Most importantly, your intellectual preparation and commitment to evidence-based reasoning contributes to cultural and social contexts that could accommodate contact confirmation with wisdom, rather than panic. The next 18 hours and 37 minutes represent a threshold in human history that we cannot step back from. Either we confirm that the universe occasionally produces natural objects so unusual that they challenge our understanding of physical processes, or we confirm that artificial technology exists beyond Earth and is currently passing through our solar system. Both outcomes represent paradigm shifts that require fundamental adjustments in how we understand our place in the universe. But the evidence suggests that the paradigm shift toward recognition of extraterrestrial intelligence and technology is not just possible but probable, supported by accumulated data that challenges conventional explanations across multiple independent lines of analysis. The truth is coming because the truth is already here, embedded in observations that have been accumulating for months, while institutional biases have prevented acknowledgement of their implications. October 3rd doesn't create the truth. It reveals the truth through visual evidence that will be impossible to dismiss through technical language, institutional caution, or media management strategies. The high-resolution images will either show surface features consistent with natural formation processes that somehow produced impossible natural phenomena, or surface features that clearly indicate intelligent design and construction. Given the accumulated evidence from spectroscopic analysis, trajectory calculations, mass estimates, and emission patterns, the probability strongly favors artificial origin over natural explanations that require multiple violations of established physical principles. We are approaching confirmation that we are not alone in the universe, that intelligence and technology exist beyond Earth, that other civilizations have achieved capabilities that represent centuries or millennia of advancement beyond our current understanding. This confirmation will trigger response protocols that have been developing quietly for decades, institutional adjustments that will reshape scientific research priorities, and social adaptations that will accommodate recognition of our place in a universe containing multiple technological civilizations. The preparation is complete. The capabilities are in place. The coordination mechanisms are established. Human civilization is ready for contact confirmation in ways that would have been impossible decades earlier. The truth is coming because we're finally prepared to receive it, analyze it constructively, and respond to it wisely. 18 hours and 29 minutes, until the universe tells us definitively what we've been wondering about since we first achieved consciousness and looked up at the stars. The countdown continues. The truth approaches. History waits.